Hello everyone, welcome back. So for this Line 25 list, we are done with the array problems. Make sure to check those playlists. We are also done with the linked list problems. Okay, and we are also done with all the string problems. Okay, so now I'm going to start the new data structure. But I'm going step by step so that you would understand the data structure. Like I cannot directly jump to the dynamic programming or tree concepts. So it needs to be built sequentially so that your foundation is good. Okay, so now I'm going to start with matrices. Okay, so there are four problems in matrices. So I'm going to start with the first problem. Set matrix 0. Okay, so now in this you are given an m cross n matrix. Okay, if an element is 0, set its entire row and column to 0, and you must do it in place. Okay, so suppose we are given this example, and for any row or column, if it is 0, so we need to change the entire row and entire column to 0. Okay, so this is 0, so I have to change whole row and whole column to 0. And it is also mentioned that you must do it in place. In place means you should not like in place. So basically, I'm not gonna read the whole description. So in place basically means that I don't have to take any additional data structure. Okay. Uh, because it is mentioned. Okay. If I would have to take additional data structure, I could have taken another matrix. Okay, and I would have checked that if this element is 0, so I will start filling its rows and columns to zeros. So I could have taken additional matrix, and that would have solved my problem, right? But in this case, we cannot take additional matrix. Okay. So, so now what can I do? Okay, so like I cannot take a separate matrix, or even I could have taken a hash set. Okay, hash set could have stored the indices of all the rows or columns with zeros. So I would have marked it in the hash set. Okay, but we cannot take any additional data structure because it is mentioned in the question. Okay, so now what I can do is, what I can do, I can use the first row and first column of the matrix. Okay, first row and the first column, because I'm not able to use any addition. I would have taken two separate arrays which would have stored which row and column is zero. So what I can do is I can leverage the first row and first column of the matrix to store the information about which rows and column needs to be zeroed out. Okay, so let's understand it with a diagram. Okay, so now suppose this is a matrix. Okay, 1, 2, 3, 4, 0, 5, 7, 8, 9. Okay. Sorry for the bad handwriting. Okay. So now what I have to do, I have to change this row and this column to 0. That will be my resultant matrix. Okay. So what I can do is, I can, if any element at any position, if it is 0, I can mark the first cell of the corresponding row and column as 0. Got it? So, so basically what I'll do is, so suppose while traversing the matrix, okay, if I found any row or column to be 0, I'll mark the first row and first column as 0. Okay. Now, so suppose I start iterating over here. Okay. I started iterating over the first row, it is fine. I started iterating over the second row. In the second element, I got a 0. So what I'll do is, I'll mark the first row. Okay. So first row, so this will be marked as 0. And first column, this will also be marked as 0. Okay. And now this would go on. This would go on. All right. And this would go. Okay. Then it's done. Okay. After the whole matrix iteration is done, I'll again iterate over the matrix. Okay. And if I found any element in first row or first column is 0, so I'll change the whole row and column to 0. So I'll start iterating from the first row. I found this is 0, so I'll change whole column to 0. Similarly, for this particular row, I found this as 0, so I'll change whole row as 0. Got it? So this way I can do that. But you might be thinking what if initially only I got first row or first column element is 0? Like what if this element would have been a 0? So I cannot use it as a marker interface, right? So I could take two flag variables basically to check if first row or first column contains 0. Okay. So if first row contains 0, we can take a flag and mark it as true. Okay. But it should not impact our original use case. And later on, while iterating the matrix, I'll also check the first row and first column is 0. So I'll mark them as also 0. And uh, then I would mark the separate rows and columns as 0. So I hope you got the intuition. What is the logic behind it? So let's code it out. I know that this might be a bit tricky, but once you get hold of what I'm talking about, it will be very easy. So let's check it out. So how many rows will be there? So it will be matrix dot length, right? And how many columns will be there? It will be matrix of row dot length, basically. So matrix of 0 dot length. Why I'm taking 0? Because it might have a single index as well. Okay. Now, as I was talking about, that I need to take flag for first row and first column, right? That if they are 0 or not. So I would take boolean I want to take a meaningful name, so I can take first row 0. First row 0. Okay. So it is initially false, right? And similarly, first column 0, right? First column 0. So it is also initially false. Got it? Now, firstly, as I was talking about, like we can mark the rows and columns in the first row and column if they are 0. But what if we got the 0 in the first row and first column only? So firstly, we'll check for first row and first column if it contains a 0 or not. Okay. So check, we'll make a condition. Check if a first row or first column is 0. Okay. Is 0. Okay. So now I start iterating over the first row. Okay. So now for int I equals to 0, I less than all the rows. I need to iterate over all the rows, right? I plus plus. Got it? So now, if a particular row is 0, so row means I will come first, okay? So if matrix of I comma 0, if it is 0, right? If any of the index is 0 in the first row, then this boolean will become true. So first call 0. Why first call 0? So I mean, so this matrix. So like what is happening is matrix of I 0. So 0 0 1 0 2 0. So it will check these three elements. So basically this is checking all the columns. So if any of it is 0, so first column 0 will be 2. So later on we need to mark it as okay. And if any of the column is true, so we don't need to check further. So we can break out of the loop. Okay. Similarly, I can do it for column as well. So I'll quickly copy this code. Okay. I less than columns, right? And if matrix of 0 comma I, because I need to check for column. Okay. So if it is 0, so now first row 0 will be true. And we'll break out of the loop. Okay, got it. So these two condition basically checks if first row or first column is 0. Got it? Got it until here. Okay. So now, as I was talking about, we need to use first row and first column as the markers, basically, because we cannot use any additional data structure. So now I'm going to use first row and first column as markers. Okay. Markers as in which column or which row need to be zeroed out. Okay. So now, since we checked for 0th row and 0 column, so I'll start with first index. So int I equals to 1, I less than rows, I plus plus. Okay. And I'll iterate over the columns as well. So for int j equals to 1, j less than column, j plus plus. Got it? Now, if any element is 0, so if matrix of I or I comma j, if it is 0, then in that case, I'll mark the row as 0 and I'll also mark the column as 0, right? Makes sense? So, basically, I'll mark the first row and first column as 0. Got it? So I'll mark matrix of I comma 0 as 0 and I'll mark matrix of 0 comma j as 0. So here I'm basically marking the row and here I'm marking the column, right? So this will be done, right? So now after the iteration of whole matrix, so whichever element needs to be zeroed out, whichever row or column needs to be zeroed out will be filled in the first row and first column of the matrix. Okay. Now, so we'll start zeroing it out. So I'll again iterate over the matrix. Okay. So basically, in this step, we will be setting matrix cell to 0 based on first row and first column markers, right? So now, again, I'll iterate over the first row and first column from first row and first column. So int I equals to 1, I less than rows, we already taken rows, I plus plus. And for int j equals to 1, j less than column, j plus plus. Got it? So now, if any if basically the first row or first column is 0, so if matrix of I comma 0, if it is equal to 0, or matrix of 0 comma j, if it is equal to 0, so then I'll mark whole row and whole column to 0. So I'll mark matrix of I and j to 0. So until they will iterate over whole particular row and column, it will be marked as 0. Makes sense? So this satisfies our this logic. Now, what if our first row and first column would have contained the zero. So we need to mark that whole row and whole column to zero as well, right? So, so handling, now handling first row and first column now. Okay. So if the first row boolean, what was the first row boolean? It was first row zero. So if first row zero, if it is true, if that boolean is true, means first row and first column needs to be zeroed out. So I'll do a loop for int j equals to zero, j less than columns, j plus plus, right? And I'll mark that particular column as zero. The matrix of zero, comma j would be zero, right? Don't worry if it is too much of code as well, but it's a very simple code, right? And similarly, if first column is zero, so what was my marker? It was this. So first column zero. If first column zero, if it is true, then again, what I'll do is for int j equals to zero, j less than rows, j plus plus. Okay. And matrix of no, I have to yeah. So matrix of j comma zero. Okay. J comma zero will be zero, right? I think I think this is right. Okay, okay. So so this is also done, and we don't need to return anything. So yeah, in this way, the whole matrix will be modified. So let's quickly run the code to see if it is working fine. Okay. Okay. Where's the issue? Oh, so I've used I here, but I've put J in there. Okay. All right. So the base cases are running fine. So let's submit the code. Okay. So it's running with 100% read. Okay. So now let's understand this. Okay. So basically, I started with flag for first row and first column. Okay. And firstly, we checked if first row and first column is zero. Okay. If it is zero, we mark that particular boolean as zero because we'll do this condition later on. Since we are taking first row and first column as a marker, so firstly we'll check if those contain zero or not. Okay. Then I started with the first row and first column iteration. So I basically started iterating from this row and this column. Okay. And if any element is zero, I'll mark the first row and first column as zero right here. And now I started again iterating, and if first row and first column contain zero, then I would mark it as zero. Okay. And lastly, I had checked for first row and first column. If those flags were true, I marked the whole row and whole column as zero. So see, it's a very simple piece of code. So like what will be the time complexity for this particular code? So like considering like we have m rows and n columns, and we traverse the matrix twice. So the time complexity would be big of m into n, right? And the space complexity is big of one because we have not used any additional space. We just use two Boolean variables to keep track of the first row and first column, and that doesn't contribute to the space complexity, right? So I hope you got the solution. And bit traces are like they might be long, but the intuition or things are very easy behind it. Okay. So I hope you like the video, and I'll see you in the next video. Until then, bye bye.